Okay, so now we're going to do a few things like the internal oscillator. Now, the internal oscillator, every single digital device nowadays just runs on a specific dedicated internal oscillator, and the PIC is absolutely no exception. But you can effectively change the speed of that oscillator to effectively do something different in your program, the timing wise, I mean. So by default, the PIC runs at about 1 megahertz, and there are dedicated registers just to easily control which clock source you're using because it has an dedicated internal clock, quite a few actually, and it also accepts an external clock. But so what you do first is right after your little include directive here, you just go to production, set configuration bits. Now, most of the time, you're not going to go too advanced with this. You're just going to go to this FOSC, F oscillator, and then you're just going to look for int IO67. This is going to tell it to use its internal little oscillator. After that, you're going to look for the watchdog time and enable bits. You're going to set it to off. Now, what a watchdog does is if your program, for example, is in a loop for a bit too long, then it throws your program back to the reset. And 9 out of 10 times, that's not what you want it to do, because you'd rather just have it malfunction and just see the problematic output rather than it causing a problematic output, because maybe you might intend for it to hang in an infinite loop, but the program doesn't see that way, so it just throws it back. So this watchdog timer, it's better to just set it to off just to make it run smoothly with everything else. And this little bit is very important, the low voltage programming bit. Now, a few PIC models can be programmed with a higher voltage than this one. So just to tell the program not to use the high voltage and instead just use the low voltage specifically is a very good idea, because it might permanently damage the PIC if you aren't careful. So just specifying that. And all that you do from here on out is here's a little insert source code in editor wherever your cursor is facing, and then there, configuration bit. These configuration bits aren't really necessary if you're just purely simulating whatever you're interested in. But if you're actually physically programming a PIC, then these become extremely important, especially the low voltage programming mode that I just told you about, for very obvious reasons. So now that is out of the way, what we're interested in is just changing the speed of the oscillator. So let's go back to our friend datasheet again. And then we go back to this little index and find where's the oscillator. Here is the oscillator module. And then it gives you a nice bunch of information about everything. And here, most of the time you're going to work with the specific special function register. And what's great about this datasheet is it specifies the register itself, obviously in the name, and then also it gives you the specific function of every bit and what happens if you load a specific value in each bit. So we're not really interested in this little part, so we're going to make this bit 0. And then let's say we want 4 megahertz output frequency. We need to make bit 6 to 4 101, because that means it will give it a 4 megahertz output frequency. You could do the same for 011, which will give it a 1 megahertz frequency, etc., etc. So we're going to, okay, so we go to bit 7, set that to 0. So I like to do it in a way where I just move a specific binary value. So we just 0, 1, 0, 1. And if there are any other settings we're interested in, so we go to oscillator startup, timeout, and we just, okay, so the device is running from the internal oscillator. So we need to set that bit also to 0. And the high frequency stable bit, in my experience, it doesn't make much difference. I think this is just sort of a flag to tell the thing whether it's stable or not, because if it starts oscillating, it's not stable for a little while, and then it just sets a flag to say, yes, it is stable. So let's just give it a benefit of doubt and just say it is stable. but you could also say it's not stable, makes no difference. And the system clock select bit, again, you select the internal oscillator. That little X just means don't care. So as long as you put 1 here, it doesn't matter what you put in there. So I'm just going to put 1 there. So let's just put 1, 1 at the very end, 0, 1, 1. Just to tell it, okay, yes, it's not stable. We were running from the internal oscillator. This is the speed at which we're running, just 4 megahertz as specified by the data sheet. And then we are good to go for the internal oscillator. So obviously, since we're working with a special function register, we're moving to we're doing a bank switch effectively, moving to the last memory bank and then back again just to make sure our variables play nice. So then we move the working register, this whatever is in the working register, this value is in the working register. We still need to load it into the OSCCON register. So OSCCON, you can see it actually does recognize the naming of that register because it highlights it in a little lighter shade of blue. So we got the oscillator running and everything. So a big bearing that the oscillator has is on, for example, timers and on delays. So if you want to make it a specific little delay whenever you're doing in a program, let's say you're taking a reading of something and you need to wait until something's done, then you just implement a little simple delay. So what you're doing is